you've split your application into microservices. Everything's modular and scalable until it comes to authentication. And suddenly, you see yourself duplicating logic, validating tokens everywhere, and nothing feels secure. So in this video, I'm going to show you how to fix that by building a centralized authentication service in NestJS Microservices with a clean architecture, reusable guards, and secure communication. So let's build it in the right way together. Alright, so here we have two kind of architecture that we can implement with centralized authentication service. So let's say the client wants to get the user profile. It's a protected resource, so the user first should log in into our application and get its access token. Then the user sends the request to the API gateway to get the user profile with the access token it has. The API gateway in the first scenario just forward the request to the user service and also pass the access token to the user service. Then the user service sends a request or calls an endpoint inside the Auth Service to validate the token. The Auth Service here starts validating the token, and if it is valid, it returns a response to the user service saying that the token was valid and extract the user ID out of the token and send it back to the user. So the user service now knows the request is a authenticated request and it knows the ID of the user, and so it retrieved the user data from its database and send it back to the API gateway, and then the API gateway send it back to the client. All right, this is the first scenario that we have with the centralized authentication. In the second scenario, where we kind of handle the authentication in the API gateway. It means that when the client sends a request to the API gateway actually extracts the token out of the header of the request and calls an endpoint from the Auth Service to validate the token. And then the Auth Service starts validating the token, and if it is a valid token, it sends back the data of the user back to the API gateway, and then API gateway calls an endpoint from the user service to get the user profile from the user service. So user service trusts the API gateway and knows that every request that comes from the API gateway has been passed from a authentication layer and is actually authenticated request. So which one is better is actually depends on your need and preferences. In both of these systems, we have a centralized authentication service, but I think in the second one, where we handle calling the Auth Service in the API gateway, is a cleaner architecture, but also has a drawback. We need to handle how services should trust each other. It means that we need to actually secure the inter-service communication between our microservices. I will talk about it, how services can trust each other. Actually, there are several ways to secure the inter-service communication between our microservices, and I'm going to show you how you can implement them. All right, and another important thing that you should keep in your mind is that the transport layer between the API gateway and Auth Service is a synchronous one, and it should be a fast one, like TCP or even better, gRPC. So in this video, we are going to use TCP as the communication transport layer between the Auth Service and API gateway. You can also use gRPC, and if you want to know how to do that, I have a full episode for using gRPC as a communication transport between your microservices. But in this video, since using TCP is way easier, we're going to use the TCP as a communication transport. Okay, so let's get into the code and implement this simple architecture for our centralized authentication service in our NestJS Microservices. All right, I open up a monorepo with 3 NestJS Microservices inside it. It has actually a NX workspace that inside it we have the API gateway application, which is a NestJS application, also Auth Service, and also user service. I did not anything inside them, just create the workspace and create these 3 applications inside it. So now first we need to implement the login feature in our NestJS Microservices architecture. So let me get back to the diagram. So here, as you can see, the sequence diagram of how login works in our microservices architecture. So the client calls the login API from the API gateway. It's a REST API, and the client calls this API and provides the credential of the user, for example, username and password. Then the API gateway forward the request through a TCP connection to the Auth Service. And Auth Service actually check the user credential, and if they are valid, it generates a JWT access token, send it back to the API gateway, and then the API gateway send back the token to the client. Then in the subsequent request to the protected resources of this architecture, the client should have the access token inside its request. Okay, so now let's implement this functionality in our application. So first, inside the API gateway, I'm going to create a auth controller. So I open up the terminal here and let me navigate to the API gateway application and inside the SRC of this application. So now we can use the Nest CLI for creating the controller. So NestJS, and then it is going to be inside the app module and its name is going to be auth. Okay, and also let me put the no spec flag here because we don't want to create the test file. Okay, so it creates the auth controller here inside the auth directory. And now here, we just want to create a post endpoint for login. And now here inside it, let me create the post endpoint, so add post, and it is going to be login. Okay, so it is accessible under the /API/auth and then /login. Let me create a function for that, async login, and it actually should have access to the body of the request. So the client should include the username and password of the user inside its body. So here we can have the body and its type should be an object which contains the username is going to be a string and also password which also is a string. It's better to use DTOs and validation here, but actually it's out of the scope of this video. You can see the validation episode of our NestJS full course playlist. So now here we need to call the login endpoint from our auth service here and pass the username and password to it. So we haven't created the login endpoint inside our auth service. So now we need to go to the auth service and create the login endpoint. All right, so let's do that. So now let me go to the Auth Service application. So I close the API gateway here and go to the Auth Service. First, we need to go to the main.ts file and actually configure this application to listen on TCP transport layer. So first, let me remove this lines here. And now, instead of calling the nestFactory.create function, we need to call the create microservice function. Then we need to pass the config object. But before doing that, let me actually install the NestJS/microservices package. So let me open up a new terminal here. We're on the root path of our monorepo. So here I'm going to say npm I at NestJS/microservices. Okay. If you've got an error here, you need to update the NestJS packages to the latest version. You can do that with NCU package to update your packages to the latest version. Okay. So we don't have any error here with installing the NestJS/microservices. Before starting the video, I update the packages of the NestJS to the latest version, actually to the version 11 with NCU tool. Okay, now here, first we need to pass the microservice options interface here in the generic type. So microservice options here. And then after the app module here, we're going to pass a config object here. And inside it, first we need to specify the transport layer. I'm going to set it to transport.tcp. As I said, you can use gRPC for a faster connection. If you want to do that, you can see the episode of gRPC in this course. Okay, next we need to pass the options here. And inside the options, we need to set the host address. It is going to be localhost here. So 127.0.0.1, which is the address of our localhost. And the port, which is going to be 8877. Okay, and then here, we can say await app.listen, okay? And here in the logger, we can say the application is running on TCP. And let me say the auth service is running on TCP port 8877. Okay, now in the next step, we need to create a message pattern for the login endpoint in this service, Auth Service. All right, so now let's create the message pattern for the login inside the controller of this application. So I open up the app controller here, and inside this controller, let me remove this dummy endpoint, and let's create a message pattern here. And its name is going to be something like auth-login, okay? Then we need to create a function for that. It is going to be async login, and it should take the credential of the user. So I'm going to use the add payload here, access to the body of the message. We get the credential here, and its type is going to be an object that contains username, which is going to be string, and password, which is also a string. Again, the best practice here to use DTOs here instead of this inline typing. Okay. Then we need to return the app service login. So here I'm going to say return this app service login. As you can see here, it is already injected to this class in the constructor. So we just need to implement a login function inside it. So first let me put the credentials here and then declare the method login inside the app service. You can also create a separate module for the auth inside the auth service and put the controller and services to that auth module. But since the auth service is only responsible for authentication, I just put the all logic inside the app module. Okay, so let me go to the login function here inside the app service. So as you can see, we have a login function which takes the credentials. Now here inside this function, we need to actually validate the username and password and then create a JWT token and send it back to the API gateway. Okay, so for the validating the username and password, we need to actually keep the user's data inside a database, and you know how to do that. We just need to set up Prisma or TypeORM here, and this just makes this video too long. So let me just do a dummy validation here. But first, let me put a warning here, say that it is for a demo, and replace it with the DB logic in production. Okay, now here we just say if the credential, the username equals to something like admin and the password equals to something like password, then this is a valid user and we need to create the token for that. Also in the production, make sure to hash the passwords inside your database and use the bcrypt or argon package to compare the password with the hash version inside your database. I have a fully explained authentication episode in our NestJS full course, but here we are focusing on microservices, and these database logic and encryption are the same when you have a monolith application. So if you want to know how to do that, you can see the episode on authentication in our NestJS full course. Okay, now here we need to create the JWT token. So in order to do that, we need to actually install the JWT service inside our monorepo. So I open up the terminal here and install the nestjs/JWT. So here npm I nestjs/JWT. With this package, we can sign an access token and also verify the access token. And then we need to actually register this JWT module inside the app module. So I go to the app module here, and in the import section, we're going to use JWT module, the register. As you can see, the JWT module comes from the nestjs/JWT package that we have just installed. So here, I'm going to pass an object here. We need to set this secret, and here, let me just hard code it here. But we should not do this here. Instead, we need to actually read the secret from a env file. And in order to do that, we need to configure the config module for our NestJS application. And again, since we have a fully explained video about how to use the env variable and config module in our NestJS application, we don't go over them again here. It just makes this video too long. Okay, so if you want to know how to use config module to retrieve your env variables, see that episode from our NestJS full course. Now, also we need to expiration time. So we're going to use the sign in option here. And inside the sign in option, we need to set the expires in. I'm going to set it to 1 hour. Okay. And again, let me emphasize that keep your secret out of your code base and put it inside the env variable, then use the config module to retrieve that secret here and set it to secret option in the JWT module. All right, let's save this. And now let's get back to the app service here. And here we can use the JWT service to create an access token for the user. So here, first we need to create a payload. So const payload and set it to an object. We need to set this up here, which is going to be ID of the user. Let me, for example, set it to 123 and set the username here. So credentials, the username. And also we need to have a role, for example, and set it to admin. Okay. As you can see, all of these are hard coded, but in a real world application, we're going to use the database logic to get these data from the database. Okay. Let me put this into a block here. So all of these are inside the if block. And then we need to create the token. Before doing that, let me fix this typo here. It's going to be payload. Okay. And now we can create the token. So const token. And now we can use the JWT service here. So in order to do that, we need to inject the JWT service here. So let me inject it in the constructor, private JWT service, and set it to JWT service class. It comes from the NestJS/JWT. Okay. Now let me get back here and say this dot JWT service dot sign and then pass the payload. So here it will use the options that we have set here inside the app module with the JWT.register function. It uses this secret and this sign-in option. Let me get back here, and here we just return the token back to the client. And else, if the credentials are not valid, we can throw a new error, for example, invalid credential. So I'm going to say throw new unauthorized exception, say invalid credentials. Okay, so that's it for the logic of creating the token and sending it back to the user. Now here, as you can see in the app controller of the auth service, we call this login method that we have just created. And now let me get back to the API gateway, go to the auth controller, and here in the login API, we need to call that endpoint from the auth service. So let's do that in the next section of this video. All right, so in order to call the auth login endpoint of the auth microservice here, we need to register a client module for the auth microservice. So I go to the app module here. We are in the API gateway application. And here in the import section, we're going to use the client module to register a client for the auth microservice. So here I'm going to use client module, register, and then pass a list here. Inside the list, the first client that we need to register here is the Auth microservice. So we're going to set the name to something like Auth Service. We need that name when we are going to inject this client into our Auth controller. Okay, then we need to set the transport to transport.tcp. This Auth microservice listening on TCP transport layer. And then in the options, we need to set the same option that we have here in the auth service. So let me just copy this host and port and paste them here. So the auth service client send the messages through the TCP to this endpoint. Now let me get back to the auth controller here, and we need to inject it inside the constructor. Use @inject and then put the name of the service. It is going to be Auth Service. The best practice here is to save these keys inside a constant so we don't need to hard code them every time we need to inject them inside the constructor. All right, then we need to define them here. So private read only auth client and set it to client proxy. Okay, now we can use this client proxy inside the login endpoint. So here we can just return await this auth client send. So you can see here we have two methods for sending a request to the auth client, the send and emit. If we want to get back a response, we need to pass the send. And if we don't need to wait for the response, we need to use the emit. So if we send here in the auth microservice, we need to use message pattern. And if we want to use emit for an asynchronous communication, which means that we don't need to wait for the response. We need to use event pattern in the auth microservice. So we use message pattern, and now we can use the send here to wait for the response back from the auth microservice. So use the send here, and we need to put the message pattern that we have used in the auth microservice. It is going to be auth login. Let me make sure that it is the auth login. So here we have a message pattern. Yes, auth dash login. So here in the auth controller of the API gateway, we can use the same message pattern, and then we need to pass the body that we have here as the message body. It contains the username and password. If I hover on this, it returns observable of any. We cannot use a wait for this observable. Instead, we can use the first value from function from the RxJS, which is for converting an observable into a promise. So then we can just resolve the promise. So I use the first value from, which is a function from the RxJS. As I said, it converts the observable into a promise. Then we can await for this promise that comes from the auth client that send function. All right, we're done with the login API in our authentication system, and now we can test it. All right, so in order to test this, we need to run all application inside this workspace. So I use nx run-many and then use tflag-t for the target serve, which runs the application. This command runs all application inside our workspace, Auth Service, User Service, and API Gateway. All right, let me wait for that. All right, so as you can see, the Auth Service is running on TCP and the API Gateway application running on port 3000. And here we have an error which says that the port 3000 is already taken. And that's because we haven't configured the user service. So it is by default listening on the port 3000. So let me just fix that. Go to the user service and here in the src and main.ts. For now, let me just configure it to listen on port 4000. We need to actually change that to listen on TCP, but for now, let me just quickly fix that. Okay, now let's go to the Insomnia to actually call the login endpoint. So here we call the localhost 3000, which is the address of our API gateway, and then /API/auth, and then /login, which is the post endpoint that we have created inside the API gateway. So let me just send this request with this body, username admin, and password equals to password, the hard-coded user that we have checked inside the auth microservice. So let me send the request. So as you can see, we have the access token here. Let me get back to the application and go to the auth microservice. So here we have the auth microservice. Let me put the token inside an object here. Okay. And get back to Insomnia and send the request again. Now we have a token here which contains the access token of the user. So the API gateway forward the request to the auth microservice, and the auth microservice generates the token and send it back to the API gateway, and in turn it is sent to the client by the API gateway. Now the login function is working without an error, and now we can move on to the next section of this video, in which we are going to protect our endpoints inside our microservice architecture. All right, guys, we're going to go to the next section of this video, in which we are going to protect some resources in our NestJS architecture with our centralized authentication service. So here is the scenario. We are going to protect some endpoint from the user service. So first, the API gateway expose get endpoint for getting the user profile. This endpoint is going to be protected inside the API gateway. So we're going to create a guard for this endpoint. And when the client request comes at that endpoint, first it goes through the guard that we are going to create. It's a little different from the passport guard that we create in a monolith application. We're going to see how we can do that in this video. So the request goes to the guard, and inside the guard, we are going to call the Auth Service for validating the token of the user. So inside the guard, we're going to check if the user has a token inside its header. And then if it does, we're going to call the Auth microservice to validate that token. if the token was valid, the Auth microservice send the user data back to the API gateway. And then inside the guard, we're going to allow the user to access to the get endpoint that called in the beginning of this process. Then inside that endpoint, we're going to call the get profile endpoint of the user service to get the user profile. So as you can see, the authentication takes place in the API gateway microservice, and the user service actually trusts the incoming request that comes from the API gateway. As I said, we're going to talk about how the microservices can trust each other in action. So now let's implement this scenario and create the guards for protecting the microservices resources. All right, if you're ready, let's get into the code. All right, so I get back to the Auth microservice here and open up the app service inside the Auth microservice. And here in this service, we are going to create a validate token method. So let me just remove this dummy endpoint here. Okay, and now let's create another method here, async validate token. It takes the token, which is going to be a string, and then inside it, we are going to actually verify the token. So I'm going to use a try catch block here. I'm going to say const decoded equals to this, the JWT service. We have already injected that inside the constructor, and then call the verify function here, and then pass the token to it. Okay. So if the token is valid, it just decode that and retrieve these values that we have put inside the token. Otherwise, if the token is not valid, it's just thrown an error. So here in the next line, we can make sure that the validation was true. So we're going to return an object, say valid equals to true, and then put the user ID here. It is come from the payload.sub. So the payload is decoded here. So decoded dot sub, and then we can put the role of the user to the decoded dot role. So as you can see, we have a role here in the payload when we are going to create that token. So decoded dot role. Okay, we can also create a type for that to have type safety here. So now we need to put the catch block here. If we have an error when we are trying to verify that token, it means that the token is not valid. So we can just return an object, say valid is false, and put the user ID as null and also role as null. Okay, so this is going to be the simple validate token function here inside our service. Now we're going to create a message pattern for validating the token, so the API gateway can send a message to that message pattern. So I go to the app controller of the Auth microservice, and here we're going to create a message pattern again. As I said, message pattern are for sending back a response to the client. An event pattern are just used for asynchronous communications. Inside them, we don't need to return a response to the client. And actually, the client don't wait for the response from the event pattern. Okay, so here, since we need to return a response to the client, we need to use a message pattern. I'm going to use a pattern for that, validate dash token. Okay, and then we're going to use a function for that, async validate token. Get the token here. It is going to be a string. Actually, we need to put the payload decorator before it. Okay, and then here we're going to return this, the app service dot validate token, and pass the token to it. Okay, now we can send a message to this message endpoint from our API gateway. So now let me get back to the API gateway, and here inside it, let's create a controller for the users. So I open up the terminal here. Let me turn off the dev server and go to the apps, then API gateway src. Here, let me first clear this up. Let's use the Nest CLI for creating controller, NestGCO, and then inside the app, we're going to create a user controller and then dash no spec, because we don't want to create the test file for that. Okay, so here, as you can see, we have the user controller here. Let me close the terminal and open up the user controller. And now here inside it, we're going to create a get endpoint for getting the user profile. It should be protected. So first, let me put a get endpoint here, create a function for that, async get user profile. Okay, and then it should return the user data. So how we can get the user ID to see what profile the client is requesting? Actually, we need to extract the user ID from the token of the user. So first we need to actually protect this endpoint. We're going to create a guard for that, and inside the guard, we are going to validate the token with the Auth microservice and then get the user data out of it. So let me open up the terminal here. Now let's use the Nest CLI again for creating the guard. NestGU, which stands for guards. It is going to be inside the guards directory, and then its name is going to be auth. Okay, and then put the -- no-spec. All right. So here, as you can see, we have the guards directory here. Let's open that. And as you can see, it's a class that implements the canActivate function. So it needs to define a canActivate method. And in this method, we need to determine if the user is allowed to activate the target resource or not. If we return true, it means that the user can activate the target resource. And if we return false, it means that the user should be blocked and it's a unauthorized access. So now let's define the logic here in the canActivate function. So first we need to actually extract the token out of the request object. In order to do that, first we need to access to the request. So we can use the context here, which is the execution context, to actually access to the request object. So here I'm going to say const rec equals to context dot switch to HTTP, because we are going to use it to protect the get endpoint, which is a HTTP endpoint, and then call the get request function, which actually returns the request object. Now here we need to access to the auth header where the token actually should exist. So I'm going to say const auth header and set it to rec.headers, and then provide the key, which is going to be authorization. So the access token should be inside the header of the request inside the authorization. Okay. Then here we can check if the auth header is not exist. We can just easily throw an unauthorized exception. So here I'm going to say if not auth header, then throw new unauthorized exception saying missing token. Okay. Now if the auth header is existed, we need to extract the token out of it. So usually the token is a bearer token, which means that it actually prefixed by a bearer and then the token here. Okay. So we need to split the auth header by a blank space and then get the second value, which is the actual token. So in order to do that, I'm going to say const token equals to auth header that split. So it is going to be as a string. So let me just cast it as string here. Okay. So now we can access to the split function, and we need to specify the delimiter, which is the blank space. And then after the split, we're going to take the second value. So we put 1 here, which means that we want the second value. Okay. Now that we have the token, we need to actually validate that token. And we're going to do that with the help of the Auth Service. So we need to send the request to the Auth Service. In order to do that, we need to actually inject a client proxy for the Auth Service. So let me go to the Auth controller here. Here, as you can see, we have injected the Auth Service as a client proxy. So let me copy that and get back to the AuthGuard here and create a constructor here. And inside the constructor, let me just inject the auth client. Okay, so let me just import the client proxy and inject from the NestJS/common. Okay, let's save this. And now here we can send a request to the auth client. So I'm going to say const result equals to this dot auth client dot send, and then specify the message pattern, which is validate token, and then put the token here as the body of the message. All right. So I've already talked about it. It sends a observable. So in order to wait for this response, we need to wrap it inside the first value from function from the RxJS. It turned this observable into a promise. Then we can easily wait for that. Okay. Let's actually turn the canActivate function into an async function so we can wait for the promises inside it. So if I go back to the Auth microservice inside the app service, you can see if the token is valid, we will return an object, and inside it we set the valid to true. So we can actually check if the result dot valid is not true. It means that the token was not valid. So here we're going to say if not result dot valid, Okay, we can throw a new unauthorized exception again here saying that invalid token. Okay, otherwise it means that the token is valid, and then we need to actually extract the user data from the result and append it to the request object. So then inside the user controller, we can access to the user information from the request object. So let me get back here, and we're going to say the user equals to an object. We need to set the user ID. We're going to set it to result.user ID and role to the result.role. Okay. And finally, we need to return a boolean from this function indicating whether the user is allowed to access the target resource or not. So we just return true here. Okay. As you can see, we throw unauthorized exception if the token is not existed or is not valid. So if one of these two happens, we do not reach this line return true for this can activate function. And we have an error here, and that's because we just return a promise of boolean. So let me just remove this types here. So it just return a promise of boolean. Okay. Now let me get back here and let's decorate this get endpoint with the AuthGuard. So I'm going to use guards decorator and pass the AuthGuard to it. Okay. Now after can activate function returns true, we can access to this function, and we are sure that now the request object has a user appended to it. So we can say const user ID equals to rec. So in order to access to the request object, we're going to use the rec decorator. Then we can have the request object here in the parameter, then .user ID. Okay. Now we need to go to the user service and create a message pattern for returning the user profile. So let's do that. Okay. So I go to the user microservice and go to the app controller here. Let me remove this dummy endpoint. I'm going to use a message pattern here and say its name get user profile. Okay, then we're going to create a function for that get user profile. We need to have the user ID. So I'm going to use the add payload to access to the body of the message and get the user ID, which is going to be a string. Then we're going to return the app service that get user profile. We haven't declared this method, so let me just call that and then declare that in the app service. So get user profile and pass the user ID to it. Now let me just declare this method and go to the app service. Let me remove this semi-function here. And we have the get user profile inside the app service. So let me just put a dummy list of the user here. We have the user with the ID 123 and the name John Doe. Okay. And then here, search through this dummy list of user to find the user with this user ID here. It's a really simple user service. In a real world application, as you know, you need to use databases. But for now, let's just keep it as simple as possible to make this video shorter. Okay, let's get back to the app controller of the user. Let's save this. And now let me get back to the API gateway user controller, and then we can send a message to the user microservice. So in order to do that, first, we need to actually register a client for the user microservice. So I go to the app module inside the API gateway. And here, as you can see, we have already registered a client for the Auth Service. We just need to do the same for the user service. But I think we did not configure the user service to listen on the TCP transport layer. So let me go to the main.ts of the user. And yeah, it's just listening on the HTTP endpoint on port 4000. So let me just fix that. Let me just paste the code to configure this microservice listening on the TCP with port 8878. And let me say user service is listening on TCP port 8878. Okay, let's save this and get back to the API gateway app module, and then just copy this, which is for registering a client proxy for the Auth Service, paste it here and just rename it to user service. It's listening on TCP transport layer, and we need to change the port to the 8878. Okay, this is the port of the user service. And now we can go to the user controller and inject the client proxy for the user. I go to the Auth Service first and just copy this get back to the user, create the constructor here, and just paste the line for injecting the client proxy. We need to change the name to user service, okay, and change the name to the user client. Now we can use this inside the get user profile. So we're going to say const user equals to this, the user client dot send, and we need to put the name of the message. It was get dash user dash profile, okay? And then we need to pass the user ID to it. So this is a observable. Let me put a $, here, indicating that this is an observable. And then we can use first value from RxJS to turn this observable to a promise, and then wait for that and return it back to the client. All right, I think we're done here. And now let's run the applications. So let me open up a new terminal here. We are in the root path of our workspace. So nx run many -t serve. Okay, it's run 3 microservices: Auth Service, User Service, and API Gateway. Okay, the Auth Service running on port 8877. The User Service also running on this port 78, and API Gateway are running on port 3000. So now let's test this application in Insomnia. Okay, now let me send a request to the login endpoint. Okay, we get the token here. Let me copy that and get back to the other request. It sent a request to localhost 3000/API/user, our endpoint for getting the user profile. So here, as you can see, we have an auth header. Let me disable that. It means that we do not send the authentication header to the endpoint. So let me send the request, and here we have an unauthorized message saying that missing token. Let me open that, and here let me remove this and replace it with the token that we have just copied. And here, as you can see, we have a bearer prefix here. That's why inside the AuthGuard, we split it and take the second value, which is the token here. So now let's send the request with the token. You can see the user profile here in the response. Now let me just tamper with the token. Let me remove the first letter and send the request again. And here we have invalid token with an unauthorized exception. Okay, let me just put it back and send the request again. Now we can have the user data that comes from the user microservice. So yeah, in this way, with this centralized auth service, we can do the authentication process and guarding inside the API gateway, and then pass only authenticated requests and authorized requests to the other microservices. So you might have a question in your mind. How user service should trust API gateway? I mean, how user service makes sure that this incoming request is coming from the authentic API gateway, not a service that actually a fake API gateway from an attacker. Don't worry, this is the exact topic of the next few episodes in this course. There are several ways to implement how microservices should trust each other inside a microservice architecture. We're going to go over all of the method for implementing how microservices trust each other in a microservice platform. So if you haven't subscribed to the channel, please subscribe to the channel and hit the like button. It doesn't cost you anything, but it means a lot to me and help me a lot to move forward and create these tutorials for you. Also, I have a request from you. Please just share this video with at least one person that you know this video is going to be helpful for them. Thank you so much for your support, and stay tuned for the upcoming episodes of this course. Have a nice time. Bye-bye.